Okay. Good morning, students. Okay, now we'll start probability. We'll go. I hope we have completed 3D, three-dimensional geometry, because we have covered every model clearly. Let us quickly recall what is probability with our previous knowledge of class 9, 10 and 11. Right? So what is probability actually? Probability is nothing but measure of certainty. Measure of happening an event. Okay, it's not a pure science because it is estimated only, and it is nearestly calculated such that there are justifiable logic and inferences with reasoning. That's why probability is not a pure science, but it was an applied science, which is nothing but if you want to know or estimate a future outcome, right? Or else, if you want to know the possibility of what is happened, out of that, what is your requirement, that is called as probability. We use the word probably. So from that only the probability is called. It is derived from the word probably. So may or may not, that is called probability, right? So we call it as the probably is nothing but the word or probably. From that it is called as probability. So probability calculation is basically with the formula probability of happening an event PE is equal to number of favorable outcomes by total number of possible outcomes. This is the formula we used to derive for the conditional or the probability finding of happening an event, occurrence of an event. Right? So number of favorable outcomes or total number of possible outcomes is nothing but okay. I think audio and video is clear. But Rudraksh, are you able to hear me? Okay. Now I am proceeding with the continuity of probability. This is the favorable outcomes by total number of possible outcomes. This part you are clear. Good. Now we'll go ahead. We are recalling the previous knowledge only. We have not started a new topic. This year there is a lot of coverage required for probability. But we are today we are just recalling the previous knowledge, right? This is already. Then what about the sure event? Event is happening of a thing or occurrence. So this is nothing but event happening of a thing or occurrence, right? Now sure event. What is a sure event? Already you know. Suppose I have tossed a coin. If I want either head or tail, one should happen because in a coin there are two outcomes, either head or tail. So if I want either head or tail means definitely it is called a sure event. But If I ask neither head nor tail, means I don't want head, I don't want tail, then it is called an impossible event because one should happen. So, impossible event, the probability is of E is equal to 0. For sure event, probability of E is equal to 1. Whatever other probability which is neither sure event nor impossible event, yes, that is called a probability of equally likely outcomes. Equally likely outcomes are those occurrence of instances that there is chance of happening any of the events equally. Probability of happening any of them is equally. Suppose probability of head, if I toss a coin, is 1 by 2. Probability of tail is also 1 by 2. Then what is the sure? Definitely probability of head or probability of tail must and should happen. So it lies between 0 and 1. And similarly, probability of tail also lies between 0 and 1. So the probability of an event which lies between 0 and 1, exactly I call it as less than only, sure. Because 1 is already we named as sure event, 0 as impossible event. So if the event of a outcome or the outcome or the probability of an event is lying between 0 and 1, then this is called the equally likely outcome or equally likely event. Equally likely event lies probability between 0 and 1. So the probability of equal likely event lies between 0 and 1 because it is every time equally chance are possible to get, right? Now we are saying sure event, impossible event, probability of what is the formula, equally likely event. This part we know. This is the previous knowledge. Next, what we learned in class 11th, we applied this concept to balls, pencils, pens, things in a box, days, sure, and then we use it for playing cards. We have learned how many sets of deck of playing cards will be there, red suit, black suit. Similarly, types of the cards, there are 4 types: face card, numbered cards, and again what we have learned, we applied this for the combination of simultaneously taking 2 things at a time. This we have learned in the last year, class 11. Suppose there are 2 cards, replace without replacement. Replacement means total number of cards will be same. Without replacement means number of cards will be reduced. So this part we have learned last time, right? So we use the principle of combinations. Suppose there are 2 cards. This part I can no need to note down by you. How do you know this part? Now see, now we can say now see here, there are 2 ways of doing this one. Directly we use the help of the combination because we know the combinations, right? So n say suppose 26 into how I can write 26 into 25 by 2 into 1. Similarly 52 C2 I can write as 52 into 51 by 2 into 1. So this 2 into 1 cancels because they are dividing each other, right? So what we did by using the combination, 2 cards, there are no replacement. So by using the combinations, probability of red 1, red 2 is equal to R1, R2 I can take here because both cards are red. So R1 intersection R2 you can write, R1, R2 also you can write, we can use the same. Total red cards are 26, 26, 2 are taken by out of 52, 2 are taken. This is total possible, it will favorable. So 26 is 25, 52 into 51. Now, if you do manually without using the combinations principle, without our help of combinations, suppose we are doing manually, what is the probability of, we start with card 1 and card 2 like that. First card to be red, P of R1. Total red cards are 26. So indirectly this is 26 C1 by 52 C1. So 26 by 52, 1 card is red means total red cards 26 out of 52. Now you are taking without replacement, so automatically the number of cards will be less. After 1 card is taken out, remaining cards will be 51 and red cards will be 25. Again, you want red means in that 25 by 51. Together, both things are happening at a time. P of R1, P of R2. It is nothing but P of R1 intersection R2 or P of R1 R2. Both are same one. Is multiply both. If two things are happening simultaneously, then what happens? Multiply them in a product. One thing is happening M ways, other thing is happening N ways, other thing is happening P ways. Then the total probability is coming M into N into P, like that. So P of R1 R2 or R1 intersection R2 is equal to 26 by 52 into 25 by 51, which is nothing but 25 by 102. So this is what we can call as the probability of both cards being red. Are you clear? The probability of both cards being red. Now, there is no replacement by using the combinations. This is what you are going to see. Are you clear? So, what is you see? Probability of R1 intersection R2 is nothing but R1 into R2 only. Suppose we are taking, suppose there is one more black card in the inside. Two red cards, one black card. So, one black card again 26 are there. 26 by 50 will come because there are already two things are taken. Two cards are taken. So, like that, you will use the chain of combination of simultaneous taking of the things, happening of the things. This applies to the combination can be applied with the number of balls also. Suppose there are 10 red balls, 5 black balls. So what is the combination? What is the possibility of one red and one ball, one black, or two reds or two black balls? So we use the same principle in simultaneous happening of events. So we use the principle of combinations. Right? Now last year we used the principle of sets also, union, intersection. In that we used the intersection here, right? And delta, like that these combinations also used in the probability. Axiomatic approach, usage of set theory and usage of permutations combinations in the probability. This year we'll extend this concept to further for with no more combinations and principles of probability. So please make a note on this. Okay, yes. Now again it came. We are going to, this is the principle what we learned with the last year's concept. Right. Now we recall some terms and of a probability. So what is the experiment in the probability? Experiment. It is the happening with some defined outcomes. Right? This is called an experiment. Right? So probability as an operation. So it is the operation with some defined outcomes happening with some defined operations as an operation. This is called experiment. So these are key terms in probability, right? Random experiment. What is random experiment? We have been using these words. So what is random experiment is that it is an experiment with more than one outcome and we cannot predict before. We cannot predict with the conditions, with the following conditions. So it is called the random experiment. It has more than one outcome and we cannot predict the outcome before or in advance. This is called the random experiment. Next, outcomes and sample space. That we'll see. The possible things to happen or occur during a random experiment. Next, sample space. The set of all possible outcomes is called sample space, capital S, denoted with. Right? No. Sample point. Each element of a sample space is called sample point. Example, if a coin is tossed and head is H, tail is T, then S is equal to H comma T, right? H is one sample point and tail is one sample point. Not done. Right. Right. Now, what is a trial? We will see here. Some example. I am defining all the terms now. Trial. If an experiment is repeated under same conditions and the outcome is not same but one among the possible expected the possible and may not always repeat. It is called a trial. So if an experiment is repeated under same conditions and the outcome is not same, but what among the possible outcomes without always repetition. So this is called a trial. Suppose I have tossed a coin, right? So I know that either head or tail will come, right? So first time it may come head, second time it may come tail, third time again head, but fourth and fifth time it can be tail again, like that. We are not sure of the outcomes, but possible outcomes only it will fall, and there is no order for that to fall. There is no guarantee that again alternate will fall or countries it will fall. So we are not sure of the outcome, but it follows the expected outcome. It's not that neither head nor tail will come. So one of the possible outcomes only will come, but is not repeated and is not sure of repetition, not sure of unrepetition or without repetition. So such experiments output is called a trial. So repetition of experiment is nothing but repetition of random experiment. It is called a trial. So the trials can be generally the number of trials are n finite and n belongs to natural number because you don't have zero trials, so n is a natural number and it is called n is a finite. Okay, right. Now we discuss about event. The subset of a sample space associated with an experiment. So example, what happens if a coin is tossed, S is equal to H comma T, right? So probability of event is equal to head, right? Then head falls, head occurs. E is an event. So which is head is a subset of H comma T. So E is a subset of S right? Therefore, probability of E or probability of getting H. Okay. Generally, we name the event which is equal to 1 by 2, like that. This is called the event. Similarly, we can find the probability of tail is equal to P of E. We can as E1H, E2 also T, like that. So E1H, H subset of E1. Similarly, E2 is equal to tail, you can take. So E2 is also subset of